By and large, from what I've seen, I think algebra, y'all are quite okay. Right? That is good because a significant portion of your exams, whether it's your prelim or your N level, is going to be about algebra. Sarah, you can see the questions, right?
Yeah.
Okay, thank you. So the thing that you all need to work on is your trigonometry, okay? I would say that it's quite normal. Every year, trigonometry is like a bugbear for students. So we will strive to improve on that. Okay, let's start with the first question. This is application of rules of indices. So a to the power x times a to the power y is a to the power x plus y. A to the power x divided by a to the power y is a to the power x minus y. Okay, you all need to know this. Then a to the power x to the power y is a to the power of xy. So when you have this x to the power of 15 plus minus 3, okay, divide by x to the power of 5. This divide, I write it like this. Then this will be x to the power of 15 minus 3 over x to the power of 5, which is actually x to the power of 12 over x to the power of 5. Then I use this. Okay, this will be x to the power of 12 minus 5, which is x to the power of 7. Okay, the rules are very, very important. Okay, hi, Zaim. Come, have a seat. You are his friend. Yeah. Oh, okay. What's your name, please? Khairul. Yes. You are not an online student, right? Oh, okay. So from January, you are joining face to face. Okay. Okay, guys, I was just telling the students, can you please take this down? These are the rules of indices that you need to know very, very well. Next question, easy, very well done. Khairul, what's the common denominator of 3 and 8? 24. Try not to use big numbers, okay? I know you all can use 48, 72, 96 all, but just use the smallest possible one, or rather what we call the lowest common multiple. So this one times 8 times 8, then times 3 times 3. So this will be 8x minus 32 over 24 plus 3x over 24. And this is 8x minus 32 plus 3x over 24, which is 8x minus 32 plus 3x over 24. All right, when I want to combine the numerators, my dear friends, when I want to combine the numerators, I put brackets. Then this will be 8x plus 3x minus 32 over 24. And this is 11x minus 32 over 24. Next, we are supposed to express as a single fraction. So single fraction always revolves around the idea of having a common denominator. Now, guys, don't get too excited, all right? When you see such questions, pause for a moment first. Because why? Students like to do this, They know common denominator, they will go and do this. X plus 3 bracket x squared plus 6x plus 9 plus 2 bracket x plus 3 over x squared plus 6x plus 9 times x plus 3. Okay, students do this. Is it correct? Definitely no. Okay, as I was writing, Khairul was already shaking his head. All right? It's wrong. Okay, you're making life very difficult for yourself by doing this. So what you need to do is to go and factorize x squared plus 6x plus 9. All right, go and factorize that. So x squared plus 6x plus 9 equals to x plus 3, x plus 3. Okay, I do the tic-tac-toe method or the multiplication frame or the shoebox method. Okay, whichever way you want to call it. And this will be x plus 3 squared. So this will be 5 over x plus 3 plus 2 over x plus 3 square. Then I see daylight. Wow, so simple. All I need to do is just multiply. Okay, I just need to multiply this by x plus 3 bracket x plus 3. And this will be 5x plus 15 over x plus 3 square plus 2 over x plus 3 square. Then now I can combine already. Okay, denominators are the same. I can combine. it'll be 5x plus 15 plus bracket 2 over x plus 3 square. Then it'll be 5x plus 15 plus 2 over x plus 3 square, which is 5x plus 17 over x plus 3 square. Now, some students will tell me, Coach, why you put a plus? I mean, why you put a bracket when you have a plus? Okay, plus doesn't change anything, what, if it's a bracket. Okay, I don't disagree with that, but I want to say this again. I don't like to have this kind of thinking, right? Where, oh, plus means I don't need to put bracket, minus means I must put bracket. I don't like that. I just do for everything. Why? Because in an exam, in the heat of a moment, under time constraints, under stress, you can forget this kind of very, very small details. And then that would ultimately affect you. All right. You might think that it's small. I also think it's small, but it has a large impact on your answer. So just put bracket. Anyway, to draw brackets, it takes you maybe half a second. All right. It's very fast. Okay. Next one is completing the square. Okay, write down the steps. Take the coefficient of x, divide it by 2, and then square the results. Okay, Nurin, what is the coefficient of x in this particular equation? -6. Okay, correct. So we put x plus -6 divided by 2, whole thing square, -13 minus -6 divided by 2, whole thing square equals to 0. Okay, coefficient of x, which is -6, I divide it by 2, and then I square the results. So this will be x minus 3 square minus 13 minus -3 square equals to 0. Okay, this will be x minus 3 square minus 13 minus 9 equals to 0. X minus 3 square minus 22 equals to 0. Okay, Tinishka, what do I do next? Yes, so x minus 3 square equals to 0 plus 22. X minus 3 square equals to 22. Then by square rooting both sides. Okay, why I need to square root both sides? I need to get rid of the square so that the x minus 3 can come out. So x minus 3 equals to plus minus square root 22. X minus 3 equals to square root 22, or x minus 3 equals to minus square root 22. Then x equals to square root 22 plus 3, or x equals to minus square root 22 plus 3. So this will be 7.69 or minus 1.69. Okay. Next question. P, Q, R, and S are 4 ferry terminals. You all know what's a ferry terminal now? You take ferry and go where? Batam or Bintan, right? But Bintan is not very well liked compared to Batam. Do you know why? Both are in Indonesia, but why is Batam preferred to Bintan? Any idea? Have you been to Batam? Bintan? You? Both also know. Okay. Because in Bintan, they use Singapore dollar. All right. The currency is Singapore dollar. So everything you buy is in Singapore dollars. And what does that mean? It means it'll be very expensive. I've never been to Bintan also. Okay, my life I've never been to Bintan. But Batam is cheap because everything is in rupiah, and people love to go to Batam because they have spending power there. Okay, you go for one massage, foot massage in Batam is about maybe 10 Singapore dollars for 1 hour. In Singapore, it's about 40 Singapore dollars. Okay, so that's why people love Batam. But who likes Bintan? People who don't like crowds. Okay, they want quiet place, not many people, then they will go to Bintan. Okay. So anyway, yeah, our ferry terminals are mainly used for ferry rides to Batam and Bintan. Now, this is 146 kilometers. This is 234. This is 252. This is 67 degrees, and this is 88 degrees. You're supposed to calculate angle QPR. So one good thing, right? You all realize that when you have 3 sides, okay, when you have 3 sides, to calculate the angle, you just use cosine rule. Okay, that one you all were able to figure out. Okay, so it will be 234 square equals to 146 square plus 252 square minus 2 times 146 times 252 cosine angle QPR. Remember, this is the angle that is in focus. So 234 square minus 146 square minus 252 square equals to minus 2 bracket 146 252 cosine of angle QPR. Then go and use your calculator. Okay, 1879 over 4599 equals to cosine of angle QPR. And angle QPR equals to cosine inverse 1879 over 4599. Okay, remember guys, cosine when it goes to the other side, it becomes the inverse, cosine inverse. And this will be 65.885 degrees, round off to 65.9 degrees. Okay, as you look at this question again, I want you to ask yourself, what are the conditions under which you use the cosine rule? You use the cosine rule when you have three given sides. There's another condition. You use the cosine rule when you have. Think about that. And then friends, please round off to three significant figures. Okay. Next, we are supposed to find PS. PS is this one here. So for this, we use the sine rule. All right. Because we have this angle, 67 degrees. Then PS. Then you have 88 degrees. And 252. So using the sine rule, sine of 67 degrees over PS equals to sine of 88 degrees over 252. Question, can I write like that now? PS over sine 67 degrees equals to sine of 88 degrees over 252. Can I write like this? Why? Why cannot write like this? Okay, but actually I still can find the distance of PS with this. But there's something wrong, right? There's something very wrong with this. Guys, I said before, okay? So please remember this. You have the angle as your numerator. You must have your angle as a numerator here also. All right, so here you have your side. Here you also have your side. But you see over here, I have my side as my numerator, angle as denominator. Then angle as numerator, side as denominator. It's not consistent. Okay, it's wrong. But this is correct. I can have PS over sine 67 degrees equals to 252 over sine 88 degrees. This one can. Okay? It's like they say, you wear socks, you must wear shoe. All right? You don't wear shoe without wearing socks. Actually, you can, just that your feet will not smell very good. Okay, the circulation will not be so good. Okay, then after that, Khairul, what do you do next? How do you solve for PS? Yes, you cross multiply. PS sine of 88 degrees equals to 252 sine 67 degrees. PS equals to 252 sine 67 degrees over sine of 88 degrees. And this is 232.10 round off to 232 kilometers. Okay, next one. All right, bearings. The bearing of terminal S from terminal R is 229 degrees. Calculate the bearing of terminal S from terminal P. Okay, so you must ask yourself first, what is it that the question wants to find out? Terminal bearing of S from R. So from R means you go and put the compass at R, and this will be 229 degrees. Okay. We are supposed to find S from P. So what we need, okay, let's make the diagram a bit cleaner. Okay, we are asked to calculate the bearing of S from P. So we draw this and we are supposed to find this angle. How much is this? Okay, friends. First things first, let's do it slowly. Okay, Nurin, can you tell us how much is this angle in rate? Okay, now the issue is I want to name this angle. Okay, just to make sure that I know what I'm finding out, I want to name this angle. Okay, to name an angle, you need how many alphabets? One. Hey guys, primary 4 work. When you want to name an angle, 3 alphabets. Okay, I know why you're saying 1 alphabet because sometimes we just put like A like that, right? Okay, but actually we need 3 lah, okay? We need 3 alphabets. So we have R, we have P, then we need one more alphabet. What can we use? Do your schools teach you all these N1, N2, N3? Okay, what is N1? Basically, this is the first compass that I'm using. All right. But it can be N2 also, it's up to you. Then this can be N1. Okay, but if you don't like this N1, okay, you want to use maybe A, B, or C also can. Okay, maybe we call it B lah. Okay, to make life a bit easier for you. Because when I was a student, I found N1 a bit weird. So angle BRP, as what Nurin has said, is 360 degrees minus 229 degrees minus 67 degrees, which is 64 degrees. So what property is she using? Angles at a point. Okay, now friends, if this is 64 degrees, how much will... Remember, our objective is to find this whole blue thing. All right, this angle which is in blue, our objective, but we do it slowly. Let's first find this angle. Angle RPS, easy. Khairul, what is angle RPS?
180 minus 67 minus 88.
It's a triangle, right? Okay, so it's just 180 degrees minus 67 degrees minus 88 degrees, which is 25 degrees. Okay, this will be angles in a triangle. If you want to put angle sum of triangle, also can. Excuse me. Now the last part, we need this Okay, we need this green one here. This one we already know is 25 degrees. Okay. Once we get this green one here, then we just plus 25 and we get the answer already. Okay or not?
The green one is QPR.
No, it's not QPR. QPR is like this only. Okay, green one is from here all the way until here. It's QPR plus this small part here. Okay. So maybe that one we call it EPR. EPR, yeah, EPR. Okay, we call it EPR. You know what's ERP, right? What's ERP? What does ERP stand for? I don't know, guys. Where do you see ERP? On the roads. What does it stand for? No. What do you do when you see a ERP? You pay, right? So ERP stands for electronic road pricing. Okay? It's like when you go to Malaysia, you have those toll booths. All right? You go to Indonesia, you have those toll booths. That's what we have in Singapore. But the difference between ERP and the toll booths in Malaysia is that those toll booths in Malaysia, they are functional throughout the day, 24 hours. That means no matter what time you pass through, you have to pay. Unless the government says, okay, it's going to be toll free for these few days. Like recently, there was during Malaysia's National Day last year, the government said that for these 2-3 days, it will be toll free. Okay, why? Because they want to let the citizens go back to their hometowns and don't have to pay for toll charges. Okay, ERP is only applicable during morning time and evening time. All right. Why? Actually, when I was your age, there was no ERP in Singapore. But after that, it started. It was imposed. It was implemented. What's the purpose of ERP? It's not to make you pay lah. What's the purpose?
It's congestion.
Yes, because during this, if you notice, ERP it starts at maybe 7:30, and then it's all the way until 10 o'clock or 9:30, and then it starts in the evening 5 and it ends at about 8, and the price changes. Maybe 7:30 you pay 50 cents. 8 o'clock you will pay $1. 8:30 you will pay $2.50. All right. And like what he said is to reduce congestion, because for some people, let's say from their house, they travel to their work area in the town. They need to pay about $8 of ERP. Okay, 3 gantries. They pass by 3 gantries, each gantry $2.50. They pay $7.50, and this is only one way. Then when they go back home, they have to pay another $8, $16 per day, times 5 is $80, times another 4 weeks, because 1 month got 4 weeks, right? It's $320 just paying for toll. Who likes that? Okay, and they can easily save this money by doing what? Sleeping earlier and waking up earlier. So if they beat the gantry, a lot of people do that, me myself included. All right, purposely wake up early so that I can beat the gantry. Okay, coming back time is a little bit trickier because you have to leave work later. But some people, they are okay. They leave work at the same time, but they go and do other things, then they go back home. Depends, okay? But anyway, just for your own knowledge, because you all do social studies, you must know what's ERP for. But has it been really useful in reducing congestion? I'm not sure. I don't think so, because the roads are still very congested. Singapore being a very small country, all right? But I always tell myself, even with ERP, it's congested like this. What if there's no ERP? It'll be way worse. So that's how it has helped, in my opinion. But anyway, I rarely travel during the ERP times, so I don't really know. Okay, so guys, back to the question. How do we get this green? So just now Khairul said that it's actually this angle, which is not true because you have this small angle here. All right, but it's a good effort. So to get this small one, right, Okay, there's no way to do that. But what we can do is we can get this whole thing because these two angles, all right, they add up to 180 degrees. Okay, do you know those kind of let me draw parallel when these two lines are parallel. Okay, when these two lines are parallel, then these two angles will add up to 180 degrees. Okay, that's what's happening here. This line is parallel to this line. So it will be, let's say, EPR. Okay, angle EPR is 180 degrees minus 64 degrees, which is 116 degrees. This will be angles between a pair of parallel lines. Add up to 180 degrees. So now it's very easy already to find the bearing of S from P. Okay, which is just this green one plus this brown one. Okay, bearing of S from P is 116 degrees. Plus 25 degrees, which is 141 degrees. Yesterday, do you all have lessons or not in school? Just some activities, orientation activities. Are you all happy to see your classmates? Yes and no. Okay. You are in region sec, is it? No, right? Okay. All right. Next question. In the diagram, a 10-meter ladder XZ. This is the ladder is leaning against the top of a 8-meter vertical tall wall. Write sine of angle ZXY as a fraction. Okay, Khairul, sine means what? What over what? Yes, okay, sine is so. So sine of angle ZXY is 8/10. All right, the right angle is here. This is ZXY. So 8/10 and then reduce it to the simplest form, 4/5. Remember what I've said, the hypotenuse will never ever change. All right, the hypotenuse will never ever change. Okay, Tom lowered the ladder to B. and the ladder became 3 meters further away from the foot of the wall. All right. So he lowered the ladder from here, he lowered it all the way to B. So that's why you have this 3 meter extra distance that's covered. Ladder became 3 meters further away from the foot of the wall. Assuming that the ladder will collapse if the angle between the ladder and the ground is less than 28 degrees. Determine whether the ladder will collapse after Tom adjusted the ladder. Okay? So your job, right, is actually to go and find this angle. This is your job, to go and find this angle, because it's the angle between the ladder and the ground. All right, this is where the ladder is. This is where the ladder is, and this is where the ground is. Now, Nurin, A to Y, how much is the distance? 9 meters. How about A to B? 10. All right, do you know why it's 10 or not? Okay, it is 10 meters here. But why is it 10 meters here also? Okay, so he's right. You're using the same ladder, right? The ladder just slant, but the length of the ladder will not change unless you go and eat a bit of the ladder or you go and cut off part of the ladder, which was not done, right? The same ladder is being used. Okay, so it's more of a logical answer lah. Okay, the length, I mean the hypothesis, sorry, the length of the ladder is always 10. Okay, so now AB is 10 meters, AY is 9 meters. So cosine of angle BAY is 9 over 10. Angle BAY is cosine inverse 9 over 10, which is 25.841 degrees. Then we can write, since the angle between the ladder and the ground is less than 28 degrees, the ladder will collapse. Okay, we have to write a concluding statement. Because ultimately the objective of the question is to get us to determine if the ladder will collapse. Okay, guys, we go for a 10-minute break now. And then after that, we will continue with trigonometry. Do you have the trigonometry notes?
And
Don't think so. Okay. Can you take it out and show it to him?
I have the number one I reckon too.
Okay. Can you ask her, show her this design, pass it to Okay, let's go back to trigonometry. Now for the checkpoint test, okay, I suggest go home and redo the questions. Do not think too much about it, all right? But it's more of how you want to work on your weaknesses and what you want to practice more on. Okay, let's look at the next question. In the previous lesson, we were talking about the cosine rule. So that's what we are going to focus on. Okay, so we have this figure here. This is 103 degrees. This is 90 degrees. This is 51 degrees. This is 35 degrees. This is 40 meters. This is 46 meters. And this is 73 meters. So how do you find DCE? Okay, angle DCE, you go and find using sine rule. Okay, then BE, the length of BE, you can use simple trigonometry, tua kaso, because you have angle, you have 46 meters. The length of AB, okay, once you get BE, you can use, you can find AB using cosine rule. So this one you use cosine rule, this one you use sine rule. Okay, and then the area of triangle CED. CED. You use half AB sine C. Okay, guys? Half AB sine C, yeah? But of course, to use half AB sine C, you must know what is this angle, which is easy, because once you know this angle, you just take 180 minus 35 minus that to get that. Okay, I give you 10 minutes. Go and do parts A to D now. All right, go and do parts A to D now. Then E, I will help you all out. Dinishka, is it okay? Which part are you at?
Still A.
Okay. Do you know how to use the sine rule?
Yeah.
All right. So can you tell me for part A, using the sine rule, what will it be? Sine what over what? Remember, this is the angle we want to know, right?
Yeah.
So sine of angle DCE over,
Sine C.
no, not yet, not yet. Remember, sine of an angle over the side.
Oh, 73.
Yes, 73 equals to, so now we use another angle, sine of angle, which is 35 degrees, right? Over 46, correct. Okay, this is how you use sine rule. Then next thing you cross multiply. Okay, you cross multiply. So 46 sine of angle DCE equals to 73 sine 35 degrees. Then sine of angle DCE equals to 73 sine 35 degrees over 46. And angle DCE. Okay, Noreen, the sine, go to the other side, what does it become? Sine inverse. Okay, we say sine inverse. So sine inverse 73 sine 35 degrees over 46. And this will be 114.482. Round off to 115. No, that angles we write out round off to 1 decimal place. 114.5 degrees. Any issues?
Before the calculator says 65.
Okay, I was waiting for someone to ask me that. All right. So you do this in your calculator, right? You get 60 something degrees. Then how? Why I choose 114.482? Why I never write 60 something degrees? Any idea? Because when you look at an angle, does it look like an acute angle to you? You know what's an acute angle, right? Less than 90 degrees. Does it look like an acute angle to you? No, it does not. It definitely looks like a obtuse angle. And then you know about this rule, right? Sine of, let's say, 30 degrees equals to sine of 150 degrees. Do you know about this? You know, right? Sine of 20 degrees equals to sine of 160 degrees. Sine of 45 degrees equals to sine of 135 degrees. Okay? So the question is a little bit tricky in that sense, because sometimes you are blindsided. Okay, not that we want to be blindsided, it's just that we are not cautious enough. So this is the angle that we are talking about. Okay, next, the length of BE. So, Nurin, what do you use for BE? Do you use sine, cosine, or tangent? Tangent, right? Because this is my opposite, this is my adjacent. So, tangent of 51 degrees equals to BE over 46. And BE is equals to 46 tangent 51 degrees, which is 56.805, round off to 56.8. Okay now. So this will be 56.8. Then now part C. How do we find the length of AB? So I told you just now to find the length of AB, we use cosine rule. Okay, cosine rule, the conditions either you have 3 sides or you have 2 sides and an included angle. So what did I say is an included angle? It is flanked by 2 sides whose lengths you know. All right, included angle is flanked by 2 sides whose lengths you know. So this will be KAB AB square equals to 56.805 square plus 40 square minus 2 times 56.805. Okay, I don't know whether enough space. I think I better write again, because I want it to be clear. AAB square equals to 56.805 square plus 40 square minus 2 times 56.805 times 40 cosine 103 degrees. Okay, I know it's a bit small. Okay. Okay now, guys. So after that, you go and Work it out. All right, key this whole thing. Key into your calculator. AB square will be equivalent to 5,849.037, and AB will be square root of 5,849.037. And this will be 76.479, round off to 76.5. Okay, usually cosine rule will have a lot of decimal places, okay, but we cannot run away from it. At the end of the day, we have a calculator, so we make good use of that. Yes? Any issues? Are you all classmates?
The primary school.
Oh, but secondary school, not the same. What school are you from?
Secondary school. Newtown.
Newtown. Oh, Newtown is one in Clementi area, right? Dover, Clementi. Okay. Okay. All right. I want you all to go and do D and E. E. If you're not sure, I can help you out. All right. It's a little bit different, the concept, but try to read up on this. Okay, and try doing examples 1, 2. Okay, quite easy. All right. Angle of elevation, angle of depression. So try to do these questions. All right. Example 1, example 2, and practice 1. These are all using your Tuakaso, so you should be able to manage. Okay, friends. So next week is the start of your first full schooling week. All right, first full schooling week. Yesterday was like get back to school day, then go for weekend. So have a good week ahead, and I'll see you next week. Okay, take care. Bye bye. Bye, Sarah.